Okay guys, now we're going to take notes on the rest of section P2, which is radicals and rational exponents. This is one of my favorite videos I saw over the summer, so I thought I'd use it and cheer you on, because this is the last part of our lesson. I know you guys can do it, and I hope y'all are being great for Miss Vanna. So, I hope the sound works.
Oh, you're not just going to walk away and give up.
Stuck.
You can get that. That shit in there confused me. The one right there. You get it? Yes. All right. Yes.
I'm sorry. I think that's hysterical. Okay, so now we're going to start with our lesson. I hope you have your stuff out so that you can take some notes. Radicals and rational exponents. Okay, so just like in the last lesson where I drew you a little picture at the beginning, I'm going to do the same. Might be a perfect labeling you might expect to see on your test. So this is the nth root of a. Of course, this is called the radical sign. Two words, radical sign. The a is called the radicand. And the n is called the index. So if I write the square root of x, the index is 2 and the radicand is x. I can write the cube root of y, and 3 is the index and y is the radicand. Notice that when it's a square root, we don't write the 2. We don't write the index. It's an understood square root. For any other, you have to write the number. And it kind of sits inside that little v of the radical sign. Okay, so the square root of 36. What is the square root of 36? 6. Negative square root of 36. Negative 6. I hope you're responding to me. This is the cube root of 125 over 64. What's the cube root of 125? 5. And the cube root of 64? 4. Okay. How about the fifth root of negative 32? If I'm asking for the fifth root, then I'm asking for groups of 5. So that's going to be 4 times 8, 2 times 2, 2 times 4, and 2 times 2. So a group of 5. So the fifth root of 32 is 5. No, it's not. It's 2. Sorry, it's 2. But what about this negative? If I multiply a negative 1 an odd number of times, it'll always be what? Yes, it'll always be negative. So the fifth root of negative 32 is negative 2. Okay, to hopefully help that make more sense, what's the square root of negative 4? And when we're asking for a square root, it's something times itself. So we all know that the square root of 4 is going to be 2. But can it be negative 2? No, it cannot, because negative 2 times negative 2 will always equal positive 4. So there is no square root of negative 4. So for now, you can just click no solution. And how about the cube root of negative 8? That's going to be negative 2. Okay, the principal square root. If n equals 2, and what is n? It's the index. We use the square root of a instead of writing it like this. And the square root of a is known as the principal square root and refers only to the positive square root of the number. So, the square root of a is known as the principal square root and refers only to the positive square root of the number. So I know you've heard the square root of 4 equals plus or minus 2. But with the principal square root, from now on, when I ask you what the square root of 4 is, you're going to say 2. The plus or minus will come back into play later on in the school year. An example of where that, I guess you could say, is allowed, or why that is if you think about the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, the plus or minus is included in that formula. So clearly you wouldn't take the square root and say it's a plus or minus and then stick another plus or minus on it. And this all follows the principal square root. So from now on, when you're asked the square root of a number, you're only going to respond with the positive. Okay, what would be the fourth root of 10 to the fourth? Well, if we're taking the fourth root, which means we're looking for groups of things happening 4 times, then 10 to the fourth means 10 times 10 times 10 times 10. Therefore, the fourth root of 10 to the fourth would be 10. Okay, let's look at the laws of radicals. We have laws of exponents, we have laws of radicals. Okay, the first one of those laws is the nth root of a times b is equal to the nth root of a times the nth root of b. And we'll work examples for all these in a minute. The second law is the nth root of a divided by b is equal to the nth root of a divided by the nth root of b. I'm sorry, I'm having pen troubles here. Number 3 says that you have the m root of the nth root of a, then that equals the mn root of a. Put a star next to this one. Your question is why? Can you prove to me next class why this is true? Okay, some examples. If I give you the square root of 32, which I know we've been discussing this, but to show you the laws, if you do your factor tree, we could say that that is 16 times 2, which I could expand to be the square root of 16 times the square root of 2. The square root of 16 is 4, and the square root of 2 is fully simplified. So that's your final simplified answer. If I give you the square root of 75x cubed, well, that's the same thing as saying the square root of 75 times the square root of x cubed. And the square root of 75 is the same thing as the square root of 25 times the square root of 3, and then times the square root of x cubed. So the square root of 25 is going to be 5. The square root of 3 stays, that's fully simplified. For the square root of x cubed, we're looking for groups of 2. So there an x gets out, and then here an x stays in. So the answer is 5x square root of 3x. If I give you the fourth root of 5x to the fourth. Here we have the fourth root of x to the fourth, so that's 4 x's being multiplied together, and we're looking for groups of 4, so that means an x gets out, but the 5 will not, so that remains a fourth root of 5. If I give you the cube root of 24, we could say that that's the cube root of 8 times the cube root of 3, We could also say that that's the cube root of 4 times the cube root of 6. We could write it as the cube root of 2 times the cube root of 12. You're trying to think of the factors that are going to be the most beneficial to you for simplifying. Well, the cube root of 8 is 2. So that means a 2 gets out, and you're left with a cube root of 3. So that was the easiest way to go to get to 2 cube root of 3. Next, if I give you the 4th root of 27 divided by the 4th root of 9, well, when I first look at this, I don't know the 4th root of 27, I don't know the 4th root of 9, but I do know that this can be rewritten all under the radical as the 4th root of 27 divided by 9, and 27 divided by 9 is 3. So I can just rewrite this as the 4th root of 3. That third law of radicals that you were given was the cube root of the square root of 10. And that said that you multiply the indices together. So here you can see that the index is a 3. For this inner radical, it's a 2. So 3 times 2 is 6. So our answer is the 6th root of 10. You try these two on your own. The cube root of 24, a to the 4th, and the cube root of negative 40, x to the 6th. Try both of these on your own, and then we'll go over them. Okay, when we look at this first one, I'm going to assume that the factors don't just jump out at you. They should be 3 and 8, because we can take the cube root of 8. But let's say you don't see that. Well, let's just pick the factors 4 and 6. 4 factors to become 2 times 2, and 6 factors to be 2 times 3. And if I'm taking the cube root, I'm looking for groups of 3. So right there, I can say a 2 is getting out, but a 3 is staying in. So that's the cube root of 3 remaining. Then for the a's, I can just write out 4 of them. And again, I'm looking for groups of 3. So that means an a gets out, and an a is left in. And that's my final answer. Here, I can take the cube root of a negative, because a negative times a negative times a negative will be a negative. So let's do the factor tree for 40. I'm going to pick 4 and 10, so that's going to be 2 times 2 and 2 times 5. Cube root means I'm looking for groups of 3, so here a 2 gets out and a 5 is left in. And you have to ask yourself, what about the negative? Well, the cube root of negative 1 will still be negative 1, so the negative comes out also. Then I can write out my 6 x's. And I'm looking for groups of 3. So there's a group of 3, and there's a group of 3, which means an x gets out here, and another x gets out here, and x times x is x squared. So my final answer is negative 2x squared times the cube root of 5. Next we have rationalizing the denominators. Rationalizing the denominator is one of those things like using your salad fork and not using it for your steak. You're expected to know how to rationalize a denominator. Here, if I give you 5 divided by 2 square root of 3, you are not allowed to leave radicals in the denominator. So for me to cancel the square root of 3, I need to think, what do I multiply to the square root of 3 that'll make it cancel? Well, if I multiply the square root of 3 times the square root of 3, that will be 3, and that will cancel it. But then I have to follow the rules of fractions, which say, what you do to the bottom, you must also do to the top. So I have to multiply the top and the bottom by the square root of 3. Ultimately, the square root of 3 divided by the square root of 3 just equals 1. Therefore, I'm not changing the value of this fraction at all. 5 times the square root of 3 is 5 square root of 3. And here, square root of 3 times square root of 3 is 3. And 2 times 3 is 6. So the answer is 5 square root of 3 divided by 6. Okay, let's do another one. 3 divided by the square root of 2. I need to rationalize the denominator. So if I multiply the square root of 2 by the square root of 2, that'll cancel. So what I do to the bottom, I must do to the top. Here, 3 times the square root of 2 is 3 square root of 2. In the denominator, the square root of 2 times the square root of 2 is the square root of 4, which is 2. So my final answer is 3 square root of 2 divided by 2. My next one is the square root of 2 divided by 5 square root of 7. So if I want to cancel the square root of 7, the square root of 2 is fine. It's in the numerator. That's allowed. I just need to get rid of the square root of 7. So I'm going to multiply the denominator by the square root of 7. And if I do it to the denominator, I need to do it to the numerator. So the square root of 2 times the square root of 7 is the square root of 14. Divided by, well, the square root of 7 times the square root of 7 will be 7. And 5 times 7 is 35. So my final answer is the square root of 14 divided by 35. Now let's say we don't have a square root. Let's say the index is a 3 and I have a cube root of 5. Well, your initial thought is going to be to just multiply it by the cube root of 5 divided by the cube root of 5. And if we do that, in the numerator I will have 2 cube root of 5 divided by the cube root of 25. Because if it's a cube root, how many am I looking for? 3. Well, by multiplying by the cube root of 5, I only have 2. So this equals the cube root of 25. So I should be multiplying by not just 5, but by 5 squared. So let's try it again. I'm starting with 2 divided by the cube root of 5. And I need to multiply by 2 more cube roots of 5. So I need to multiply by the cube root of 5 squared. So in the numerator, that's going to be 2 cube root of 25 divided by, and this is going to be the cube root of 5 cubed, which is 5. And that is my final answer, not this one. Okay, one more rationalizing the denominator. If I have 2 divided by 3 plus the square root of 7, here I'm looking for what's called the conjugate. The conjugate is what we will multiply to the numerator and the denominator. If I multiply by the square root of 7 in the numerator and the denominator, what I get in the numerator is 2 square root of 7. Well, in the denominator, I have to distribute. So 3 times the square root of 7 is 3 square root of 7, plus the square root of 7 times the square root of 7 is 7. Well, that didn't cancel it for me, so that didn't work. So you have to think back to Algebra 1 when you learned about foiling, multiplying binomials together. We're going to multiply by 3 minus the square root of 7. And so therefore, 3 minus the square root of 7 is called the conjugate. So in the numerator, we have 2 times 3 minus the square root of 7. And in the denominator, we have 3 plus the square root of 7 times 3 minus the square root of 7. Now, of course, we have to multiply all that out. So in the numerator, 2 times 3 is 6, and 2 times negative square root of 7 is negative 2 square root of 7. Now the denominator is where it gets a little bit more complicated. We're foiling. So 3 times 3 is 9. 3 times negative square root of 7 is negative 3 square root of 7. The square root of 7 times 3 is 3 square root of 7. And the square root of 7 times negative square root of 7 is negative square root of 49, which is negative 7. And this is what you were looking for to happen. A negative 3 square root of 7 plus 3 square root of 7 is going to cancel. So in the numerator, we have 6 minus 2 square root of 7 divided by 9 minus 7, 2. And then, of course, it's fractions. So if 6, 2, and 2 are all divisible by the same amount, we can simplify. So this becomes 6 divided by 2 is 3, minus 2 divided by 2 is 1, so that's just the square root of 7. If I lost you there, remember, 2 is a common denominator, so it's the same thing as saying 6 divided by 2 minus 2 square root of 7 divided by 2. 6 over 2 is 3, minus 2 over 2 cancels to 1, so the square root of 7. Okay guys, we are not finished, but I'm going to give you a 2-3 minute break just to stand up and stretch your legs.